everyone. Today we would like to explain about the triple pendulum system. The triple pendulum system is popular calculation about the mechanics. Now we assume the three types masses, M1, M2, M3, and these masses connected with the wire. We define the wire length as L1, L2, and L3. At that time, we define angle of each wire. First one is phi 1, second one is phi 2, and the third one is phi 3. Then we can calculate a Lagrange equation. So Lagrangian is defined with a combination of kinetic energy and the potential energy. So kinetic energy can be defined with this equation. So first term is corresponding to the velocity of x-axis, and the second term is velocity of y-axis. And the potential energy can be defined with this equation. Then we can calculate the position of each masses. So about the M1, so x-axis can be calculated with this equation. So this x1 is corresponding to this length, and the y1 is corresponding to this length. Then we can calculate the velocity of x1 and the y1. So next is second mass. In the case of mass 2, we calculate the sum of this length and this length. Then we can calculate the L1 sine phi 1 plus L2 sine phi 2. On the other hand, so y2 is a combination of this length and this length. So first term is minus L1 cosine phi 1 minus L2 cosine phi 2. Then we can calculate the velocity of x2 with this equation, and the velocity of y2 like this. Third, so we consider about the mass 3. In the case of mass 3, so the first term is L1 sine phi 1. So this length is corresponding to the x1, and the second is x2, and we add the x3 terms like this. In the case of y3, so we calculate the minus L1 cosine phi 1 and the L2 cosine phi 2 and L3 cosine phi 3. So this length is corresponding to the this length plus this length plus this length. Then we can define the velocity of x3 prime and the y3 prime. Okay, so once we can estimate this value, so we can insert this value into the formula of kinetic energy and the potential. In the case of kinetic energy for mass 1, so this term can be calculated with this equation. U1 is defined with the y1 and mg. So by calculating this term, so we can get this equation. In the case of kinetic energy, so we can calculate the sum of square velocity like this. Then we can calculate this term, and this term. But in final term, so we can start the two terms with the cosine. Then we can simplify the equation like this. Finally, so we insert the length of y to the potential energy. Then we can get this equation. Finally, let's calculate the kinetic energy and the potential energy of M3. So first term is kinetic energy. So we calculate the square of velocity for this one and this one. Then we can get this term. So this calculation is almost same as mass 2 case, but we need to care about the three combination of three cosine. Then we can get this equation. In the case of potential, so we calculate the M3G and the first term plus second term and the third term. Then we can get this potential energy. So finally, so we calculate the sum of all kinetic energy and the potential energy. Then we can define a Lagrangian like this. So once we can get the Lagrangian, so we just insert this equation into the Lagrange equation. So in this case, we have a three parameter, phi 1, phi 2, and phi 3. Calculate the three types equation of motion for 1, 2, and 3. Next step, we calculate a Lagrange equation. So this term is corresponding to this term, taking a Lagrangian. So we can calculate this term like this. Then we can calculate the differential equation for dt. then we can get these equations. So finally, we calculate the second term. Second term is like this. So by calculating the second term, so we can get this equation. Then finally, we can calculate the equation of motion like this. In the case of equation 2, so we can also calculate the equation of motion by inserting a Lagrangian into this equation. Then in this term, so we can calculate these equations. So we can multiply the operator of dt. Then we can get these equations. So in the case of second term, we can also insert a Lagrangian into this equation. Then we can get the three terms. Finally, by combining these terms, so we can also get the equation of motion for second equation. Okay, finally, so we insert the Lagrangian into the third equation. Then we can get these terms. So we also multiply the operator like this. Then we can get these terms. And the second term is corresponding to this term. So we can get the three terms. And finally, by combining these terms, so we can calculate the third equation of motion. Then by combining the equation 1, 2, and 3, we can describe the equation of motion for triple pendulum. So thank you for watching this movie. So see you next time. Bye.